Right, hey y'all, it's Mr. Kyle, Myers Mathematics, and let's jump into it. We're going to talk about the inverse chain rule. So there is not technically a chain rule that works the same way for integrals, but there is a little trick you can do with certain integrals that's kind of like if the chain rule had an integral version. So let's look at an example where we're not doing this trick rule yet, and then we'll compare it. Let's say we want to take the integral of the cosine of 3x plus 1, 3x plus 1 dx. So if you're not using this trick method, you might need to say, okay, well, then I need a u sub. I need a u sub, and the best thing to pick for u subs a lot of times is whatever the inside function is. Think chain rule, the thing that you would need to do the chain rule of if you were taking the derivative instead. If I was taking the derivative of cosine 3x plus 1, it'd be negative sine of 3x plus 1. Then I would times by the derivative of the inside, the 3x plus 1, and that derivative would be 3. So you're thinking the same thing when you're choosing a u sub. Where's the inside? And I often make the whole inside part the u sub. So if I take the derivative of u with respect to x, it would just be 3. So du is equal to 3x. And, oh, hold on, 3 dx. Back it up. 3 dx. I knew something fell off there. And let's get it in terms of dx. You don't necessarily need to. If I'm going a little slow, I apologize. But I like to go slower I'd rather go too slow than too fast. So du over 3 is equal to dx. And we want to go ahead and plug in our stuff. So it's going to be the integral of cosine of u, and then we're going to sub out the dx with du over 3. And we could pull out the 3 if we wanted to, but it's kind of optional. Sometimes I do, sometimes I don't. It's just kind of nice because it makes the problem look easier. It doesn't actually make the problem any easier, but I don't know. It's kind of up to you. So the integral then would be the sine of u with a 1/3. And that is because the derivative of sine is cosine. So the integral of cosine would be sine, or the antiderivative. Then we would change it back. That's almost getting cut off at the bottom there. So I think I'm going to write it right next to it instead. So 1/3 sine of 3x plus 1, and then that's plus c. And there we go. So that's what it would look like if we're going to do a u sub. If we're going to do just the inverse chain rule instead, so same problem, but now we're going to do the inverse chain rule. So the chain rule says I would take the derivative like normal, and then I times by the derivative of the inside. This new chain rule says that I take the integral like normal, so I take the integral like I would normally, and instead I divide by the derivative of the inside. But I'm going to change what this says here. Instead of dividing by the derivative of the inside, I'm going to say divide by m. Because this only works if the inside is of the form mx plus b. If the inside only works if the inside is mx plus b. right? So it could be less complicated than that, but it can't be more complicated than that. So for instance, if it had just said 3x instead of 3x plus 1, that would have been fine. And if it was the cosine of a constant, then that would be a totally different story. But if it was just 3x or if it's 1/2 x or something like that, that would all be fine. So all I'm going to do is take the integral. So I just take the integral sine, and then I divide by the slope. So I would divide by 3, and then, of course, plus c. And look at that. I get the same answer with way less work. So you get the same answer. Now, again, it only works if the inside is linear. If it's not linear, then it won't work. It's just a little trick method. Saves you a lot of time for any questions that you would normally be using usub for, but you don't need to use usub. You can just do this little trick instead. So hopefully that's helpful. Go check out the 5 math mistakes everyone makes and how to avoid them. It's a free guide I have on myersmathematics.com. Go check it out, free PDF guide, and I'll catch you in the next video. Blessings, y'all.